Hey music friends, I've got a super dorky connection to math and music today for you. Very simple. If you understand fractions and you know anything about the keyboard layout, you'll be able to catch on. So in a typical octave, we have 12 notes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 notes in an octave. Now 12 is a really cool number because it's the first number in the series of natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on. That's what we call an abundant number. And what that means, it's kind of cool. Is if you take all the divisors of 12, meaning you can divide 12 by 1, you can divide it by 2, you can divide it by 3, you can divide it by 4, you can't divide it by 5, you can divide it by 6. If you add up all of those divisors, it adds up to 16, which is more than the number itself, which is pretty unusual. There's a lot of numbers that do that, probably an infinite number of numbers that do that. But most numbers don't do that, which makes it a pretty cool number. So you might think of each of those half steps as 1/12 of the way to the next octave up. So if you think about one half step as 1/12 of the way, we can think about two half steps as 2/12 of the way. So if we have two half steps, that's called a whole step, or we can think of this as 2/12 of the way up an octave. Now, if you're a dork like me, you see 2/12 and you think, okay, well, that's actually just 1/6. And sure enough, you'd be right. And the connection here is that this is 1/6 of the way to the next octave up. Meaning that if we go two half steps 6 times, 1, 2, 3, 4, 5, 6, it takes us an octave up. Pretty cool. This is what we call the whole tone scale. It's not used for a whole lot, but there are certain applications. So kind of cool that 2/12 reduces to 1/6. We see 6 intervals when we go 2 half steps at a time. Let's look at the next divisor of 12, which is 3. So if we go 3 half steps up, this is called a minor third. And if we go 3 half steps again, how many intervals is that? It's 4 intervals. So and 3/12 reduces to 1/4. This is 1/4 of the way up the octave, and it takes 4 intervals. Kind of cool. Corollary to that is if we go 4 half steps, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. You can consider this 4/12, which reduces to 1/3, and it takes 3 intervals to go up. This is a major third. It outlines a augmented chord, which is kind of neat. And then the last one is 6. So if we go 6 half steps, 1, 2, 3, 4, 5, 6. So this is what we call the tritone interval. 6 of 12, of course, is half, reduces to half. So 6, the tritone is halfway between the octaves. Now we skipped one, right? And the one that we skipped is 5/12. This is where it gets really cool and super dorky. So if you go 5/12 of the way up the octave, 1, 2, 3, 4, 5, and then 5/12 again. This does not get you to the octave, it skips it, right? And 5 is not a divisor of 12, which is no coincidence. So what that means is if we want to get back to the octave, we have to find the least common multiple of 5 and 12. You probably never thought you'd hear those words again. But sure enough, the least common multiple of 5 and 12 is 60. And guess what? When we start at this C and we go 5 half steps at a time, 1, 2, 3, 4, 5, and then 5 more, and continue this in intervals that we call a fourth, it makes this circle of fourths, and it touches every single note on its way back to C. Guess how many half steps that is? 60. Least common multiple on a keyboard. Kind of cool. Okay, if you stuck around this long, you'll appreciate the next part too. So if we go beyond the divisors and we say we've looked at 1/12, 2/12, 3/12, 4/12, 5/12, and 6/12, what if we look at 7/12 and up from there? If you go up 7/12, makes an interval called a fifth. And just like the fourths, where this can't be reduced, it goes around the whole keyboard, and it takes the least common multiple of 12 and 7 half steps in order to get back to C, which is 84, which is more keys than I have on this keyboard. Cool. 8/12. All right, 8/12. 8/12 of the way. 8/12 of the way up an octave is a minor sixth. These are all minor sixths, and 8/12 reduces to 2/3, right? Kind of cool. So if we look at those first fractions that we had, 6/12 reduced to 1/2. So in one octave, we needed 2 intervals to get to the original note again. Well, if we look at 8/12, It reduces to 2/3, and guess what? It takes 2 octaves and 3 intervals to get back to the same note again. Kind of cool. Let's look at 9/12. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is called a major sixth, and 9/12 reduces to 3/4. And guess what? It takes 3 octaves and 4 intervals to get back to the original note. Kind of cool. Same thing, we can keep going. With a minor seventh, if we went up 10 half steps, this would make a minor seventh. It would take us 5 octaves and 6 intervals to come back to the original note. And same thing with a major seventh. It would take us 11 octaves and 12 intervals to come back to the original note. Kind of cool. Well, you must be a dork if you're still here. I hope you appreciated this. And there's one more super nerdy little tidbit that I'm going to share with you. So we can split an octave up into 1/6 of the octave. We can split it up into 1/4 of the octave. We can split it up into thirds, and we can split it up into half. What happens if we split it up into fifths? Now, you can't really do this on a keyboard, but you can in reality. So if we take 12 and divide it by 5, it doesn't make a whole number, right? But it does make 2.4, which is not a note on the keyboard, but it is a note that exists. So if we were to go from C, and we were to go up 2.4 half steps, what is that? Well, we can go up 2 half steps, and then 0.4 half steps, we would just adjust the tuning of that note. So in between any 2 notes on the keyboard, there's what we call cents. There's 100 cents, and that's a way that we refer to the space in between half steps. And it takes 100 cents to get up to a half step. So if you were to adjust the tuning up 50 cents, that would be halfway in between 2 notes. If the note that we're after is 2.4 half steps up, then we want to go up 2 half steps and then 40 cents. 0.4 means 40 out of 100, right? So we're going to adjust the tuning of this up 40 cents to this. Do you hear that? This was the original note. This is the new one. It's just ever so slightly higher. But when you magnify that over 5 intervals, it gets you enough of a gap that you can cut out one of those intervals and only take 5. And then what's 12 divided by 2, or 12, not 12 divided by 2, 12 divided by 5 times 2 is 4.8. So now we're going to go up 4 half steps, 1, 2, 3, 4, but add the 0.8, meaning we're going to add 80 cents to this note. So instead of this one, you'll be able to hear this one. So instead of this, it's actually this, which is almost a half step, but not quite. And then the next one, 2.4 times 3 is 7.2. So we're going to go up 7 half steps. 1, 2, 3, 4, 5, 6, 7.2, meaning 20 cents higher. Barely can even tell that one's there, but it is. Okay. 2.4 times 4 is 9.6. So we're going to up 9 half steps. 1, 2, 3, 4, 5, 6, 7, 8, 9.6, meaning add 60 cents. So that, instead of this, we're at this. And then 2.4 times 5 is back to 12. Back to C. Really weird scale. It only has 5 notes, so I'm calling this the even-tempered pentatonic scale, which no one is ever using for anything at all. But this is what it sounds like. It's really trippy. So the reason these notes are not on the keyboard is because they're not part of the harmonic series in physics and stuff. So please don't ever use it unless... Well, I'd be really curious to find out if anybody ever finds a use for this scale. I'm curious to edit this and put it back together and see what it sounds like, because it probably sounds pretty awful. Anyway, hope you enjoyed this. I learned something, and I imagine you did as well. Cool. Thanks. See ya.